In this video, we'd like to review some ideas that perhaps you've seen in other mathematics courses. The first idea might be the idea of a set. Mathematicians often organize numbers into different groups that we call sets. A set is nothing more than just a collection of objects. The easiest group of numbers are called the natural numbers, and they are the numbers 1, 2, 3, 4, 5, and so on. The counting numbers. Mathematically, we write this down this way. We use this symbol right here called set braces to indicate that the item is a set. And then we put the numbers in a pattern inside the set, like 1, 2, 3, 4, and because I'm getting tired of writing these numbers, I go ahead and put 3 little dots there to indicate that this goes on in this pattern without end. Another set of numbers are called the whole numbers. The whole numbers are nothing more than the numbers 0, 1, 2, 3, 4, and so on. You'll notice that the whole numbers are very similar to the natural numbers. The only difference is that the whole numbers have the item 0 in them, while the natural numbers do not. Another set that is sometimes useful is the set of integers. We can get through life pretty well with positive numbers and 0, but sometimes we need negative numbers. Some examples of where we use negative numbers in real life are temperature. You might go outside on a cold winter day and the temperature might be minus 5 degrees Fahrenheit. Or maybe you've overspent your bank account and you have negative $10 in your bank account. Or maybe on the last play in football, you lost 20 yards. So those are ways that we sometimes use negative numbers. The set of all the natural numbers, the positive numbers, whole numbers, and 0, and the negative numbers are called the integers. And we write this down this way. Dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 with set braces around them. Notice that all the whole numbers are included inside the integers. So we have natural numbers, whole numbers, integers, but a lot of times in life we need fractions. Maybe you're measuring something and the measurement isn't just 5 feet, it's 5.5 feet, or 5 2/3 of a foot. So sometimes we need fractions. The rational numbers are all numbers that can be written in the form a over b, where b is not 0. These are all the numbers that can be written in fraction form. Let's look at some examples of fractions. So let me get ready here, take a look at some examples of fractions. Here's a fraction, negative 15 over 31. Well, certainly negative 15 over 31 is written in the form a over b, where b is not 0, a being negative 15 and b being 31. So that is definitely a rational number. How about the number 3 4/5? 3 4/5 is what we call a mixed number. And what that means is 3 plus 4/5. And you could write 3 as 3 over 1, because 3 and 3 over 1 mean the same thing. And you might remember from earlier math classes that to add two fractions, you need a common denominator. The common denominator is a number that both 1 and 5 divide. In this case, that number is 5. 5 goes into 5 and 1 goes into 5. So I can multiply 3 over 1 times 5 over 5, top and bottom. That gives you 15 over 5, plus 4 over 5 gives you 19 over 5. Now here we have a rational number, a over b, where b is not 0. What's another one? Well, negative 8. Negative 8 is certainly can be written as a fraction. It can be written as the fraction negative 8 over 1, and that's a over b, where b is not 0. By the way, we could also write this as negative 16 over 2. That's another way to write this. But in any case, it can be written as a fraction. So that means that this is a rational number. Decimals. You might remember from earlier in your mathematical career that this means the tenths, hundredths, thousandths place, so 0.125 is 125 over 1,000. That is certainly fine to write it that way, but that is not what we call reduced. You can reduce it by saying 125 times 1 is the same as 125 times 8 is 1,000. And then, since this fraction bar means division, these two divide out, and you end up with 1/8. In any case, these two fractions are both written in the form a over b, so this is a rational number. Minus 14.56 also can be written as a fraction in a similar way to these. What about square root of 25? Square root of 25 is 5, and that, of course, can be written in the fraction 5 over 1. So each of these numbers here are rational numbers. What this shows you is that integers also can be written as fractions and are also always rational numbers. So all integers are rational numbers. Well, we can draw a diagram that helps us illustrate a little bit of this. If I put all the natural numbers in here, so these are the numbers 1, 2, 3, 4, 5, so on, then the whole numbers might be in this circle. The whole numbers being this entire circle. What's outside here? That's nothing more than just the number 0. And then the integers, we could draw another circle like this. And the integers are everything inside of this circle. So what's out here are the negative numbers, like -3, -2, and -1. And finally, the rational numbers, like this. And the rational numbers, everything inside this circle is a rational number, so all natural numbers, all whole numbers, all integers. But a rational number, the numbers out here are numbers like, well, minus 15 over 31. Fractions that cannot be reduced to whole numbers. So let's see if we can look at this example. Write the number to which each of these belong. 4. Well, 4 is certainly a natural number, but since all natural numbers are whole numbers, yeah, 4 is also that. 4 is also an integer, and because you can write it as a fraction, we can write 4 as a rational number. -9. -9 is not a natural number or a whole number, but it is an integer, and it is a rational number. 0. 0 is not a natural number, but it is a whole number, an integer, and a rational number. 1.5. Well, 1.5 is 1.5 or 3/2. That's certainly not a natural number or a whole number or an integer. It by itself is only a rational number. -8 over 11. Same thing. -8 over 11 belongs only to the rational numbers. Square root of 16. You might remember that the square root of 16 is 4. And so the square root of 16 belongs to this one, this one, this one, and this one. 1 2/3. 1 2/3 again is not a whole number, is not a natural number, is not an integer, but only can be written as a rational number. And finally, be a little careful with this one, 30 over 6. Can you reduce 30 over 6? Sure you can. 5 over 1, which equals 5. So 30 over 6 belongs to all of these. So that's a little bit about grouping these numbers to belong to all of these. Okay. Not all numbers are rational. Take, for example, the square root of 3. This number cannot be written as a fraction, and we'll see why later in this class. This is an example of what's called an irrational number. Another example might be the number pi you might have heard of. The rational and irrational numbers together are called the real numbers. So that's a little bit about sets of numbers. Let's now talk a little bit about some skill review, just some things like decimal notation, number lines, and fractured computations. Change each of the following fractions to decimals. Well, how do you change a fraction to a decimal? Remember, this bar means divide. So this is 5 is your divisor there, so is your divisor. So 2 divided by 5. Well, 2 divided by 5, we could do this by hand, and you could put a little 0 there. You say this is point. How many times 5 go into 20? That's 4 times. So that gives you that 2 divided by 5 equals 0.4. Minus 5 3/8, well, that's going to be minus 5 plus 3/8. And again, 3/8, you might do this way. 8 goes into 30. Well, 8 goes into 30 3 times. You subtract, you get 6. You say, all right, 60. How many times does 8 go into 60? Okay, you might realize that that's 7 times. And finally, 8 goes into 40 5 times. So this is 0.375. Now, you might be saying, boy, I'm getting kind of tired of doing these problems by hand. Can I use my calculator to do them? And the answer is yes. And I'm going to take a look at my TI-84 calculator to do the other two problems here. So, to do use the TI-84 calculator, the very first thing you do is you press this on button down here. You can see it way down here. Okay, if you press the on button, you might get something on the screen. I right now have something on the screen from something I was doing previously. If you don't have that, that's okay. I'm going to hit second mode, and eventually I have this clear home screen here. Now, to do 5 6, all I have to do is 5 divided by 6, and I hit enter, and this tells me the decimal representation of that fraction. Now, you'll notice those 3's went on forever, so we write that either like this or like this. How about minus 11 over 12? Well, where's the negative sign on your calculator? The negative sign is this right here. This symbol right here for the negative sign. So I'm going to do minus 11 divided by 12. And you'll notice this is minus 0.9166666667. Now I have to tell you that 7 isn't really a 7. What they did here is round this digit. You only display this many digits, these 10 digits, and you rounded the last digit up to a 7. So in reality, 11 over 12 is minus 0.91666 repeated, and that's going to be minus 0.916, like this. Okay, that's one way to write that. So hopefully you remember a little bit about converting fractions to decimals. What about converting decimals to fractions? Well, we're just going to use place value. 1.25 is 1 and 25 100ths. Okay, that's the hundredths place. 25 100ths is 1/4 if you reduce that fraction. This is fine as a mixed number. If you want to write it as a fraction, you can do what I did before, or you can do the following little shortcut. 1 times 4 is 4, plus 1 is 5, so that's 5/4. This is negative 376 over 1,000, and again, you can simplify that if you want to. Now let's say you want to use your calculator to simplify this fraction. Here's one way to do that. Put minus 376 divided by 1,000 in. Okay, that gives me this decimal. But I would like this to be a fraction. Here's a shortcut to simplify by a fraction. When you have your decimal on your screen, you can try the following. Press the Math key, and then press number 1 for fraction. And this gives me the answer, minus 47 over 125. That is the same fraction as minus 376 over 1,000, but reduced. Another concept you have probably seen is the number line. The number line is nothing more than all real numbers placed on a straight line. I'm going to write a line here with 0. We put positive numbers in this direction. So 1, 2, 3, 4, so on. And negative numbers in this direction. Minus 1, minus 2, minus 3, minus 4. But I want you to realize there's lots of numbers between 0 and 1. So draw a number line with 5 on the front and minus 5 on the left. Okay. And show the locations of the following. 2 and a third. Well, this is 2 and this is 3. This is about halfway in between, so 2 and a third might be about right here. Okay, you kind of have to estimate a little. Minus 2 is right there. Minus 1/3, well, minus 1/3 is between 0 and negative 1, and this is halfway, so I might go about right here. This might be minus 1/3. 11/4, you might have to think about that. You might have to say 11/4 is like 2 3/4, so I might put it maybe about right there. Minus 3.5, be halfway between negative 3 and negative 4. Square root of 4 is 2, so I'm going to put it right there. I'll put a little arrow. It's a little hard to see that there. Minus the square root of 1. Square root of 1 is 1, so minus 1 is minus the square root of 1. Put that there. And the square root of 2. If you use your calculator, I'm going to clear the screen. You can clear the screen by hitting the clear button. If you want the square root of 2, you'll notice the square root is above this x squared, so I'm going to say second x squared 2, and then type in a parenthesis. And that gives me the number 1.414213562. This is not a rational number, cannot be written as a fraction. This represents a decimal that goes on forever. But we have a pretty good estimate of where that is. It's between 1 and 2, and it's not quite at 1/2, so I might guess that it's about right there. So that's a little bit about the number line, and hopefully you remember that. Now, how about computing with fractions? Hopefully at some point in your life you have worked with fractions. What I'd like you to do is try these. Maybe you should pause the video while you look at these. And when you're ready, I will just show you some ways to add these together. So you might want to pause now. Here's one way to do this. Because this is addition, I'm going to look at these here. 4 plus 6 is 10. 5/7 plus 3/4. I need a common denominator. Common denominator being a number that both 7 and 4 divide. That'd be 28. Now, I'd like to change this so that I have a denominator of 28. That means I should multiply the numerator and the denominator by 4. The denominator is 28. I should multiply the numerator and denominator by 7. That gives you 10, and this is 41/28. Now, 41/28 is a fine number, but it would be nicer to be able to write this way. 41/28 is 28/28 plus 41/28. What would be left over? What would be left over is 13. 24/8/28 is 1. So that is 11 and 13/28. It's a little harder to do this sort of thing with subtraction. What I like to do in subtraction is not do what I did in this problem, but to convert these to improper fractions. The quick way to do that is to say 5 times 3 is 15, plus 1 is 16. So 16/3 is the same as 5 1/3. 3 times 2 is 6, plus 1 is 7, so that's minus 7 over 2. Now again, if you're not using a calculator, I have a common denominator of 6. What do I multiply this fraction top and bottom to get 6? I hope you see that's 2. If I multiply 2 on the top and the bottom, I get 32. Here, if I multiply 3 on the top and the bottom, I get 21. 32 6 minus 21 6, now that you have a common denominator, just subtract the numerators. 32 minus 21 is 11. I can leave it like that. Sometimes in algebra we want to leave things as improper fractions. Sometimes, however, we want to write them as mixed numbers. So that's 1 and 5/6. Division of fractions is pretty straightforward. In this case, we don't need a common denominator, but when we divide, we change this to a multiplication sign, and we divide by the reciprocal, which is 24/49. Now, these are pretty large numbers to multiply, so we can use some division here to help us. You'll notice that 49 is 7 times 7, and 63 is 7 times 9. So because this sign means division, I can divide out that 7. 12 divides by 12 by 1, and 12 goes into 24 2 times. And this is 9 times 2, or 18 over 7. And I'm going to leave it as an improper fraction in this case. Again, with multiplication with mixed numbers, I like to convert them to improper fractions. So this is 5 times 5, or 25, plus 2 is 27. 27/5 times 3/11. Okay, so this one you'll notice there really isn't anything that I can divide out. There are no common factors with these numbers. So I'm just going to do 27 times 3, or 81, over 5 times 11, or 55. And again, I'm going to leave that as an improper fraction. Most of the time, we like to do that. With adding and subtracting, we need a common denominator. So my common denominator is going to be 12. That's the smallest number that both 4 and 6 divide. What do I need to do to change 3/4 to a denominator of 12? I would multiply the top and the bottom by 3. Gives me 9/12. Here I'm going to multiply the top and the bottom by 2. And that would give me 2/12 for an answer of 7/12. That ends our discussion of the review of sets and operations.